Welcome to the final session of today here at the J Champions Conference. I got to read our speaker's name for the very first time when I was introduced to EasyMock, and now we're both top champions. How cool is that? Henri Tremblay comes to us from Canada, and he's going to be presenting Refactor together. Henri?
Hi, how are you? Oh, she disappeared already. So hi, nice to be there. All people behind the screen. I was looking at my I was looking at my chat. I don't see any comments yet. We'll go through that together. If you want to ask questions, just ask. I don't think I'll have the time to read the questions, but Jean will, and she will tell me afterwards, so I can answer whatever you want. I do hope to be there for an hour. If it lasts longer, sorry about that, but it should be interesting. And from there, let's get started. So I'm again Henri Tremblay, and yes, I'm the current lead developer of EasyMock, which is a mocking framework, and of Genesis, which is the magic thing that creates mocks underneath. I'm also the Montreal Java user group leader, and of course Java champions like everyone here, plus different little things. I'm working for Training Screen, so I'm the managing director of the Montreal office. So I'm doing their management, but also a lot of coding and technical expertise. Training Screen is a GCP representative. I'm the GCP representative for Training Screen, which means we are member of the GCP, and we're trying to make Java better in the world. From there, today we'll talk about refactoring. The idea is to look a little bit how to have fun and play with code to make it better, but also how to be able to easily test our stuff and tricks to get correct tests to then be able to refactor. If you are interested in the subject, and you should, because in general, we work a lot on code that already exists, and this code needs love through time. So to be able to improve it, you do need some refactoring. The best book about refactoring is Refactoring by Martin Fowler. This one is the second edition, which is in JavaScript. The first edition was in Java. It's almost the same. So if you want to see something in Java, you can actually read the first edition. And if you want a brand new one, you read the JavaScript one. But the patterns in there are the same. Then, the other magnificent book is Working Effectively with Legacy Code by Michael Fetters. Do read it. The book is slightly old, so it's pre-Java 5 old, which means that some tricks in there are not accurate anymore, and you should not do that anymore. But most of them are fine. So in your head, you should readapt it to whatever you should do now. But keep in mind that when you did that, there was no lambdas, of course, but no annotations, no enumerations, no generics. So it changed a lot of what's happening. Then, the entire presentation is based on one slide telling you something, and then I will kind of live code and put an image what I mean. The first one is really important. Your goal is to test. So what I mean by that is, before touching anything, you should have a test making sure something works. For refactoring, is especially important because you want to keep the same behavior as before, which means that if you need tests to make sure it has the same behavior as before. You can trust yourself. Could work, but in many cases it doesn't. You might break something and you will find it much later. However, I do it for myself. I do test everything I work on, especially when I'm refactoring. The only exception will be UI, but really the visual level of UI. So a UI, I would normally not test it. I will just visually check that it works, but there's no automated testing in there. But I try to go to the controller really quickly, and then I'm adding tests all over. However, there will be some QA team that, and that's the case for me, that will add visual testing. So they will take like snapshots of screens and check that the screens looks like kind of the normal screen using some image comparison algorithm, for example. Um, it's some other expertise, so I don't do it myself. But for everything else, I do add tests. Then then I decide how much test I need to put on something, which means when you're refactoring, first you will add a bunch of unit tests. Then I will normally run test coverage to see how good I did. I might add some tests if I missed some pieces in there, which happens really often. From there, it depends how important is the code. If I do something really highly sensitive, I'll go further. Otherwise, I might stop there. So there's some, yeah, you think about how wrong things can be when you're touching that code. And we'll talk a little bit later more about that. So the other steps I can go to is then run mutation testing. Mutation testing means that you are modifying the actual production code, and you make sure that when you do that, the tests are actually failing. So it will tell you, hey, I've modified that value and it hasn't failed, so it means you're missing a test. Because code coverage is interesting to see where you go in your production code, but it doesn't tell you if you have the correct assertions to verify that the code does what it is supposed to do. Mutation testing does that. It's really slow, so you normally do it in a really limited scope, and you check how it goes. So normally I would, if I need to, I would do that, and I will add some other tests on top of it. From there, I'm fairly safe that functionally everything is covered. However, I could add some performance testing on top to make sure I keep the same performance, if performance is important for this case. So that's the idea. Which brings me to the other rule, which is do whatever it takes to test. And I mean it, because you can be on some code and you just have no idea how to test it. It's painful. and it will require a lot of wisdom and reflection and terrible things to be able to test it. So frequently there are easy tricks to fix that. And the basic ones are, you should stop caring about the design for now, because you want to refactor, you want to add tests, so you are allowed to destroy the design if you want. And destroying the design could mean, like, let's say I want to test that thing by itself. I don't mind removing the privates here, and maybe I want to be able to hack into the prices there, but there's a final here, so I will remove the final. I'm not saying it will be permanent, but for now, I'll just remove it. I don't mind. There's a random here. The random is slightly annoying because it gives me different prices all the time. And yes, this class is terrible and ugly, so I would probably need to work with it afterwards. But for now, I just want fixed prices. So I could just create a random that returns 1, 2, 3, 4, 5, 6, or whatever to make it easier to deal with. So don't stop yourself from adding tests just because you do not want to touch the actual design. Break everything you need, do your testing, do your refactoring, and then try to put the design straight. And it's frequently way easier to do it after you cleaned up you added your test and you cleaned up with refactoring. So here, where am I going with that? Okay, yes, sorry. I have like different goals, and I'm trying to put them in the best order there is. So sometimes I'm losing where am I? I'm now. An example with the code you just saw. In general, what will prevent you from being able to correctly test code and what will prevent you from refactoring is static. So the main thing I do when I try to add tests and play with my code is removing static. Here is an example because this is, here we have a static block. These methods are static, and there are no good reasons for that. I could remove all the static, make it a concrete class, and then inject that class somewhere else. So then the question will be, when should I use static? It's only use static when you are not planning to mock ever. And when does that happen? Rarely, but it does happen in some cases. An example would be this. So here I have an add method, and add will add one big decimal to the other big decimal. This won't ever be mocked because it's weird. Like if you mock an addition of two numbers and you mock it to replace by what? A subtraction. So that doesn't make sense. So you don't want to mock that thing. You will call it as is, and even in your test, you will want it to return the normal result it does return. So for these kinds of methods, and they're rare, everything in math in the JVM is like that, but there are other examples. Creating objects is an example. So if you have like private methods creating collections, that empty list, let's say, these are appropriate to be static, but in most cases, it's not. And really do think, will I ever want to mock that thing? No. Okay, I can. This can be static then, and that's the rule. Oops, sorry, wrong number for my slides. Okay, so that said, another really important rule is code that is hard to test is bad code, and I mean it. So for me, things should be testable. If whatever you code, like if you start and you code something and then you figure that it's hard to add tests to it, it's because it's bad. What you did is wrong. You should review your design and correctly do your test. Then, I'm sorry, I was looking something. Just give me a second. Thank you. Sorry, I was looking at something on the like the presenter screen that is strange. Okay. Then where am I going there? Okay, yeah. So I'll use that for everything. If I use a framework and the framework is hard to test, I won't use it. A good framework is something like, let's say, Spring framework. When you use Spring, it comes with this test suite to help testing with Spring. That's a well-thought framework. It means they're testing their thing and also they're helping you testing with their thing. So it means they know what they're doing. If it's just unusable, untestable, there's no way to check the result. The result is some scrambled thing hidden somewhere. I just don't use these frameworks. It's not a good idea. And of course, if I'm in front of something I need to refactor and it's hard to test, it does mean that this code needs some love, but then I still need to test it. So that's where the tricks and the magical ideas comes. We'll have an example here. So let's see the example. Here we go. So we have another class here. Sorry, here this one. So this is a full application, and the main so you saw the pricer, but the actual main class is called reporting service. The idea of reporting service is to calculate a return on investment year to date. So it means it checks your cash and security position. So it's a banking market finance thing, and you then calculate what kind of money you had at the beginning of the year, so January 1st, and what amount of money you have now, and you perform a calculation to give the return on investment there. This is a really simplified way to do it. It's a wrong way, so do not do that for your own stock positions. And so we're getting the day, and then we're getting the current position, and then the securities position, then all the transactions during the year, and then we're rewinding all the transactions up to the initial cash value, and we just calculate the value of the initial and the current cash value, and we do, like a sum of three. I don't know how to say that in English. Yeah, cross calculation to tell what's the return on investment there. And it's annualized at the end. As you can see, this is about like 60 line long. It's not super readable. It's not super fun to come in front of. And of course, you've seen worse, but this is the example. And this is the code for reverting a transaction, which is not super pretty either. And now I want to refactor that thing because I need to play with it a little bit. So, oops. So I need a test. So here's my test. And what I would do in general is I would just create a basic test. So here I have my reporting service. I'm lucky because it takes no parameters. So I'm just instantiating it, and I'm passing to it a current position of 0 cash and no securities. So no money at all. And I'm expecting, of course, the return to be 0 in there because nothing's happening. It's not what I would do for everything. I will do the simplest test ever, and I will just try to see what happens with that to see if it's actually bad code that is hard to test or nice code that is easy to test. Of course, in that case, it is bad code that is hard to test because otherwise the conference will be boring. So here it's breaking. So let's see why it's breaking. So there's a length of year concept here. So now I need to dig in there. Where is my length of year? Where is my length of year? Oh, there's a length of year here. Okay, so I need that value, otherwise it's unhappy, which means I get to the singleton here. And this is getting a preference here. So I'm getting a preference from some map, yes, here. I'm returning it, and the other solution is to get it from system properties. Getting from system properties is not my favorite thing. We'll see why, but let's start with that. So here, I actually need to set my system property. And because I want to start a tiny refactoring here, I will extract a constant from there. I'll move it to public. Here we go. And I go back to my test. Here we are. And then I can give it a try. Oh, it's passing. Woohoo! I get my 0. So that's great. Then while I'm there, I'm looking at my test. This is not that good because this is a big decimal. I'm converting it to a double, so I could lose precisions in there because big decimal is a really strict value. Double is the best we can do on floating points, so maybe not the best. And actually, especially in finance, but in whenever you're doing calculation with a big decimal, in general, you're expecting a scale. So you want a certain number of decimal, and this is part of the functional specification, or it should be part of the functional specification. In my case, this code is expecting to have a number with 2 decimals at the end. So it should be rounded up to 2 decimals if needed. So the decimals are actually important. And this assert equal doesn't consider that. So if I want to fix that, I would need to do something slightly uglier like this and say, okay, I want a plain string, and that's the number I want. So actually, I recommend not to do that and to use a library I love, which is called AssertJ. So my next comment is use AssertJ. If you don't know about AssertJ, it's a fluent interface kind of thing. So you start with assert that, and then depending on the parameter, it will give you a lot of little functions here. So if it's a list, you will have contains, contains only, contains in order, is empty. Here it sees a big decimal, so I have is negative. And one of the fun thing is the is equal to can be compared with a string. And if I do that, it does something like this, but it will give me a really nice error message, and it is extremely useful. It's like a bit like Hamcrest with way more matchers. You don't need to learn them because it's a fluent API, and the error message are 10,000 times better. So I heavily recommend that you use it. Now, we can check if now that I'm making sure I have the correct decimal is still working. This is still working, so I'm happy. But I did something really bad, which I'm not cleaning after myself. When you do a test, you want to leave the JVM in the same state as before, which means you should close all the threads you started. You should clear all the system properties you've added, and ideally you should destroy all the singleton you've triggered to be instantiated. It could be a lot of work, but that is what will make your test suite reliable afterward. In this case, I should ideally do something like that to clear the property I've set in. Or there's JUnit contrib, there's a library with a rule. This is JUnit 4. I'm using JUnit 4 for today. And this will actually restore my system property to what they are. So now I'm happily cleaning after myself. So that's good. But I would like to do something better than that. Because this length of year, that's cute, but it's not that great. Ideally, what I really wanted is to get rid of this singleton and be able to give a value to preferences correctly. So to do that, I could use something like PowerMock, but I don't. I'm not saying you should never ever using PowerMock, but you should rarely use PowerMock. So for those who don't know, PowerMock is a mocking library, but it allows you to mock private methods, final methods, final classes. It allows you also to mock static methods and even new. So even when a constructor is called, it lets you mock it. So and I've seen people having a bad tendency to use it instead of fixing the design, because, and I never use it. If it's something I cannot touch, I will tend to wrap that ugly thing in a new class I make to be able to use it as a correct dependency. But I really seldomly use it. And if it's required by your code to be able to test it, it means you did something wrong. But then, so in this case, I would not use that. But then to be able to do something, I need to actually modify the code, which is theoretically not a good idea. I've started to rely on what Michael Speders is saying. So his idea is use automated refactoring until testable, because it's true that sometimes you're in front of something that is actually really not testable, or it would be so painful that you just don't want to do it. Even if you're removing finals and things and break stuff around, it's still really hard to test. So his idea is you are allowed to use automated refactoring because your IDE is normally doing it right. It should not screw it up. So if you use the automated refactoring from your IDE, you will get somewhere safe. It is mostly true. You could watch out. So an example here is I will turn that into a field because I would prefer that thing to be a field. Oops, no, and I wanted to initialize the constructor. So this thing is now a field. So I got rid of the singleton called there. The constructor is initializing it the exact same way, so I'm expecting the exact same behavior. It's mostly true, but still watch out a little bit. An example is, and it happened to me with something similar. Here, get preferences gets initialized when reporting services is initialized, which wasn't the case before. So what I did is correct, but it's possible that since I moved the moment of initialization, that something is not ready for this actual initialization, which means that I might have broken something. Not big chances, but you never know. So you need to watch out. For that, what I try is this. When I code, I try to get things to explode, which means that if I do something and if it's not working, I don't want it to be some sneaky bug that will be really hard to run after to try to fix. I want a big, huge exception. Like my ideal thing, if I work on some code, is to make sure the application won't even start if something goes wrong there. And that's how I try to code everything. I want it to explode, because if things are exploding, you will find the problem, or like the first QA trying it out will find the problem. It will be really easy to find that something is not working. If you're trying to cover your trace by just logging a little warning by there and trying to return some random value so the rest still continues, and it will make it really hard to debug afterward. And life is complicated. And here it's old code, so it's not that easy, but as you like, it's an example. The length of year should be there, and this here makes the test explode directly. So that's well done. If instead of that it was doing return null, it would have taken me ages to figure out why this thing is not behaving as supposed, and why is it null, and da 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 da. So and even worse, it could have returned 0. And now I would have my calculation wrong and no idea why it's actually wrong. So trying to make things explode is extremely helpful to get your code correctly. So that said, let's go back here. So I have this here, and now I want to put my own preference there. So I just create another constructor. And here is the part where I'm cheating Michael Feather, because so far I've used only automated refactoring, but IntelliJ doesn't allow to do this one. So I still allow myself to touch the code a little bit when I feel it's okay and safe, even though I'm doing it by myself and not by automation. It can go both ways. So I'll tweak the code a little bit, and or I won't touch it with automation because I'm afraid of side effects. So I let your your wisdom be a good judge of what's correct. But the general idea is try to use automation because it will correctly move the code. And now that I'm there, I can use that new constructor. So original behavior hasn't changed. It's just getting the singleton. But now I can inject. And injecting means inversion of control or dependency injection. So I'm able to inject the dependency. And I realize that when I refactor code is most of the thing I'm doing. I'm finding ways to inject dependencies. And what you rediscover at some point is you start and you add things to constructor and slowly they percolate up and they're passed to one another. And at some point you arrive to the main method, let's say, and here you can actually remove the singleton, just pass your new instance, and then the singleton is done forever. Depending on how big the application is, it can be some work, but you normally manage to percolate like that and you're happy ever after. In this case, what did I do? I deleted this one. And so I'm coming here. And now instead of using these things, and I don't need that anymore, I will. Sorry. Okay, sorry, I'm there. So I'll add a mock. So I'm creating my mock. I'm passing it here. Fairly easy. Then I'm recording a 360. That's nice as well because now I passed a nice number, which is easier for calculation than the actual length of a year. So the 365 days, and it will work. So let's give it a shot. Now I have my mock and I have happier code and it's working. There's some warnings, but that's because it's running in Java 15. Interesting. That's because EasyMock needs to do some things that Java 11 doesn't like. But from where I stand right now, it doesn't matter. So this works, and now I have a correctly working test. Now I'll start another test. Here we go. Second test. So now I want just to add cache. So here I have a 200 current position. There's a deposit of 100 somewhere in between, and so my initial value will be 100 if you got the idea. And here is the calculation to make sure it's the correct return on investment. So if I run that thing, I hope it's working. And it's not. I forgot something. It's not. No, I haven't forgot something. It's not. It's not target 0, and the actual number should be something really big because the way it's calculated, $100 when you're the 14th of January, it means you have 50% more money in 15 days. So when you analyze that number, it's pretty good. But it's not working. So why isn't it working? This is related to time. Here, this is taking now and removing 100 days, but I'm using a year to date. So I'm starting January 1 and I'm moving forward. So this transaction is actually last year. So it's not used in my calculation right now. But this is the problem with time. When we use time like local date.time, it does move and it prevents you from correctly testing many things because it's hard to test corner cases because they happen once every year. So January 1st, February 29 is interesting. December 31st is interesting. So these days are not always the local date now. And also, if you want to move days around, there's even like if I decide, okay, though. So let's not put 2, I'll put 1. Still on January 1st, it's failing. The other thing that is annoying is that I have this big calculation here. And so that's a lot of functional wisdom in there. I'm there already. No, I want, where's my, here. I want this one. So I do not want to have complex functional code in my test. Here, I could ideally just explain how the calculation is done and give a constant. And what you want in your test, you should have no ifs in your tests. You should have nothing that moves and change around. You pass parameters to functions, and the function is returning a value. All these things should be extremely defined, and you can assert on constants. You should not have to assert on random things. An example is assert not null. Assert not null should be rarely used because normally you will know what's the actual value of that thing. If you do not, there's something wrong. Like there's little exceptions, you generate a UID or whatever, but in most cases you do know what happens. And even when you create your objects or things, everything should be super simple and there should be no ifs. It's a bit like your test code should never need to be tested because it's extremely simple. And here it's not that simple. The other thing I'm seeing here is I start to see code that it's similar between these two methods. And this brings us to the other one here. Test code is still code. So that means that you're refactoring your code, you're making your production code, you're making it nice, you're taking good care of having something really pretty, but you tend to cut and paste from test code to another test code. And this is tons of terrible code that just should not exist. So please have a look, check where it's highly similar. So here, like an example, at least here, this thing, which is my current position, is super similar to what is done in my other one. So I could create something. Here I'm create, so this is no security. I could add an array list here, so it will make it easier to add securities. Normally I wouldn't do that. It will be self-initialized, but this one is not because it's bad code. Again, I'm refactoring it. So for now, I'll put an array list here. And here I have my, I put the cache to 0. So here I'm fine. I don't need to touch anything. And here I could have done part of it by automated refactoring, but I didn't want to. And here I just put my 200. So that's an example. Maybe this could go in a before. That will be nicer as well. So I'll be quite cautious. Even this is like I would do something like this is long, like big decimal value of is lengthy is not that fun to type. So I could do something like this here. So now I will extract this to a method. Let's call it BD. Let's take, I'm refactoring. It will tell me, hey, do you want to replace all over the place? I do want to. And now I have a little BD who's taking along and doing the value up. And I don't need to type my value up ever after. And it's all nice. Of course, in the end, this thing will end up in some util library that I will reuse all over the place. But for now, it's already making my code nicer and smaller and easier to understand. So that being done, I can now check why this test is not working. Normally, I could have done it the other way around, so repair the test first and then refactor everything. I'm cheating a little bit. And there was another thing. We tend to have one test class per class. It's a bad idea. So you start with that, but don't refrain yourself from separating it in little pieces. Um, in general, the people will say you group them by team. So if you're testing one team of the class, you will create one test class with a given name. So refactoring services, reporting services underscore something, for example. Um, for me, I've discovered that I will particularly do that when I see that I'm reusing the same things in the before and the same parameters to do something. And now I have a new test that does something different, and it's not correctly using the other thing. So it's kind of breaking my really pretty pattern I used to have of reusing things in my test. So in that case, I will separate these two in a class. I could extract a base class for these two things as well if needed. In JUnit 5, there's a way to have subtest and test. You do that a lot in JavaScript. You have layers of tests embedded in one another. That's another way to do it if you prefer. Um, but please do not have like humongous test classes with tons of methods that are trying to interact to reuse things, but are not reusing fully what's configured above because they're slightly different, and that contains way more code than they should because you cannot reuse correctly because you're not separating it. So do separate it as much as you can. Then, so we're about time. So here, my actual problem is this. So I'm taking now here, and I don't want to do that. So now I would like to be able to do my own time. One possibility will be to actually pass time. And with the new Java 8 API, it means passing a clock. So you pass a clock here, and you could pass the clock here, and it will give you the time. And in this case, it's not completely crazy because I could decide that it's actually now a return on investment of a date, range of dates, and I will and I then pass the time to it. But a clock could also be an attribute in the class that I could inject the same way I was doing it before. However, I don't want to do that now because I will give you a trick that I use a lot when I don't want to move code too much. I could have used that for preferences as well. So when I don't want to move the code too much, I actually refactor whatever I want to a method like this. Then I go here. This one, I'll just remove the private, and I'll do what I call the partial mock trick, which is here. Partial mocking is something I have invented a long time ago. And the idea is, or no, and I won't say I have invented the word, so I've called it partial mock, but people were using that trick before me, before being hit by someone. I'm not the inventor of the concept. I'm the inventor of the term. So where am I? Sorry. And the idea is I still want a reporting service, but I want a special one now. So I want one. So I'm creating the mock here, but actually I would like to call a constructor to do preferences, but I want to add. So nothing will be mocked on this class except the getNow method. The constructor is still called, and then I'm getting my mock, which has the interesting side effect that now I can expect reporting services, getNow, and stop return, local date dot off. And that's fun because I have an off year day, so I can decide I'm 2021 and I'm the 200th day of the year. Then I will realize that I actually do need this value for the rest of my thing. I should not have called it like that because it's not nice. So this is my new now. So the original class still works with the local date.now, but I've mocked this so I can have my own now, which I need to use here. So that's my now minus 100 days, and then I can play and do my calculation. And here I should hopefully get the correct number. I'm not. Why am I not? What have I done? What have I done? What have I done? I don't think I will. I've done this. So yeah, I could use it. Yeah, I'll use the now. But actually, I don't need it because it's now a constant that I've set it here, so I could just move that to a constant. And so, and that's what I was saying, that the number here is now 180, sorry. So I could even do like just 180 and ideally explain where it's coming from, but I now have something much simpler to work with. I have a constant result, not a moving result depending on which day I'm running the test. Cool. So that's a way to handle time, and that's a way to get rid of whatever static there is in your class without possible side effects. So I told you before, the get preferences passed to constructor is slightly dangerous, but it's the good way to go. However, the partial mock ways doesn't change anything of the original behavior and allows you to add testing. So that's quite useful. So some other things. So it's again, this is slightly less related to refactoring, but it's something I do when refactoring. So for example, now we're able to manage time. So I'm the person decided what time it is right now. And so if I see my code, things like that. So this example here is the price service get real-time price will return a new price every second. So we wait 2 seconds to just make sure that we actually do receive a different price afterwards. But this is 2 seconds that is added to your test class, to your test suite forever. And 2 seconds is not much, but if you have thousands of tests and you're adding 1 second there, 1 second there, 1 second there, then your suite is running for 3 hours. So that's not fun. And so if you're able to trick time to tell, hey, I'm now, and hey, now I'm 2 seconds later, you have the exact same result in the end, but you're not sleeping anymore. So when doing your refactoring and when playing with time, try to do something like that. And to try to be the god of time while doing it, and do not sleep or wait or anything like that, ideally. Which bring us, it's near the end, and it brings me to, because I frequently have these questions. I'm refactoring, I'm having fun moving my codes all around and adding my tests and doing things. And then people are telling me, oh, maybe you should not do that because it might be slower afterwards. When you're doing refactoring, and even when you're coding in general, you're not doing performance tuning yet. Of course, you keep that in your mind. Of course, you won't do crazy things like you won't refactor, I don't know, an hash map to a list and do campaigns on the list. That's insanely crazy. But you are moving the code around and you don't exactly know what will be the final performance result. Most of the time, it's better. And anyway, almost all the times, it's really hard to know what's the impact. Because let's say I don't know, I'm where is my piece of code? Let's say here. So I'm here. This is calculating the position. Let's say I'm doing extract here. Calculate security position. So I do that. There's two things here. So I did that. Is it slower or faster? Hard to tell. Probably the same. But I might think it's faster because I'm calling another method now. But what you will realize is when you refactor, you will find optimizations really frequently. Like an example here, now I have better view of my code because this is all cute and tiny here. So I realize, oh, there's an initial value here. So initial value and initial seg value. So actually, I could just group them there. And why is that useful? Is because I have this here. And this is only using the initial value. So why do I need to calculate the seg position? I don't need it. So I could just actually, and I don't actually need to do anything because here I just need to, I want a scale of 2 and I don't need any calculation. I'm just returning. I have no initial value, so there's no return because there was nothing at the beginning. So I can just return that thing and it makes the code nicer. And then, okay, I continue, I move things around and, and now I get in there. So is it slower or faster? I don't know, but I feel like it's improving and it's probably actually faster, but I'll benchmark it at the end and see. And what you will frequently discover is that it's way easier to tune performance, tune code that has been correctly placed in correct places, and that has tiny methods that are really easy to read, and it's also easier to find the bottleneck. It's in this method, it's not anymore in this 70-line method. So don't think about performance, just do your refactoring, and when you're over, if needed, check if it's slower or not. Frequently, you don't need it actually, but in some sensitive case, you might need to do it. Just so then do your benchmark and use the benchmarking framework. And last thing is, or almost last thing. Last thing is about TDD, so test-driven development. So for those not aware of it, the idea is so test-driven developer will create a test, a failing test, and then they will code production code until the test turns green, and they will create all their code like that. I don't do that because I like to have a feeling of the design first, and then I will, but my tests are coming really quickly. As soon as I have something that looks like a design and my methods are not even filled, I will add the test. It actually speeds up my pace because I know directly if things are working really quickly, and unit tests are always faster than running an entire application. I almost never run the entire application. I just do it at the far end. The other thing is, it's much funnier to do it that way because it's really painful to code all the tests at the end. It's way funnier to do it while you're developing, and it feels like I'm developing. It's not feeling like I develop and now I need to test. I'm doing my development. Oh, it's working. It's green. It's turning green. It was red. Now it's green. And so I move them. When I do refactoring, however, I always do it. So I start with the test. Always. I create all my tests. I check my coverage. I see if I'm fine, and then I start playing. So I will touch only to be able to correctly test, but I won't do anything else than that. It's really important. You want to keep the behavior, and in many cases, you don't know the code, so you don't even know what is supposed to be the behavior. So you almost try it out, and you create a test, and you see how it goes. Is what you saw on the first test. I'm just running a test with no cache in position, and I see if it does something, or if it passes, or if it doesn't pass. So, so yes, for refactoring, try to TDD as much as you can. Another benefit of that is the easier the test, it means the best is your design, because as we said before, you need to be able to test, and untestable code is bad code. So if you put your test really quickly up front, you will be forced to have testable code, of course. Finally, refactoring is fun, and I like to play around and improve the code, but I always calculate my return on investment. So it doesn't only apply to market finance, it applies for my personal time. It's also sometimes called a ROTI, so it's return on time invested, which means, should I spend my time refactoring that thing, or do I have better things to do? If this code won't be modified ever again, I will probably not. If this code is fine and running and I'm not that painful to modify slightly, I won't do it. But as soon as I feel that there will be a big benefit in modifying it, because things will be better, faster, easier to maintain, less bug prone afterwards. And of course, it's a bit like experience talking here. So it's based on your feeling of how many time it will take to refactor and what's the benefit. And also refactoring is forever. So you could try to improve the code forever and ever. So you need to stop when you feel it's enough for you to be able to work with. And then maybe later when you will revisit, you will touch it again. But for now, it should be, you should not invest too much in there upfront. So yeah, keep that in mind. Don't go crazy about refactoring. Whatever you touch, it needs to bring value. Always think about the value of your end users. Cool. That's all I've got for today. Remember these two books. So refactoring and working effectively with legacy code. Then tools. Some tools I recommend. For test coverage, Jacoco is the best thing I know. OpenClover is not bad. It gives I've always found it gives a better view, but it's clunkier to configure, and the report is like hundreds of megs for EasyMux, so it's puzzling how they managed to do that. But pick what you prefer. Mutation testing, the standard is in general something called PyTest. So try it out if you want to play with mutation testing. And from benchmarking, at the simpler one is JMH to do micro benchmarks. If you want to do like real web server benchmarking, Gatling is really good. And then standard is JMeter. So ideally, I would ask you who has learned something today, and now you will tell me in the comments if you learned something today, but I don't see your comments for some unknown reason.
Oh, they're hidden so as not to distract you. But I can assure you that people did learn lots of stuff, and we also have lots of questions. Are we up to questions?
I think we are. Is that almost? Yeah, okay. Yeah, almost. So we'll go for questions. Okay, so I do hope you have learned. So if you want, so that's my list of books you should read to learn and get better. If you want, I'm giving live courses on O'Reilly every 2 months. It's about future of Java, so like new features between Java 8 and 16 now. So it's a 4-hour course. So go there if you're subscribing. I will be happy to see you. We tend to hire once in a while at Trading Screen. Not right now in Montreal, but might open. But we have offices in London, New York, and Tokyo. So if you're interested, come say hello. There's a blog post about mucking time and how to play with clock if you want, that I wrote. And this, I would really like you to give it a shot. So the code you saw here, I've transformed it into a refactoring challenge. So, and I did my own answer of what I think is the cleanest refactoring I can do. So there's a branch for that, but please clone that, try to play with it, see where you go, do a fork and a pull request if you want. I promise I will read it and see how it goes, and then read my answer to see if it's slightly similar. I'm really interested in the subject and what kind of ideas people have to improve the code. So I'm eager to see your solutions to the problem. Thank you. I'm done.
All right. So our first question is, do you have any recommendations for testing UIs, in particular Swing and JavaFX?
I'm investigating in that right now. JavaFX, I don't know. Swing, there's assert JSwing, which seems to be the best way to test Swing application. Swing is sadly a bit out of love, so it's hard to find tooling to test it correctly. Assert JSwing is nice. I'm trying to link it to things like Cucumber, and I'll see how it goes. But I have sadly no definitive answer. UI is hard, but try Assert JSwing. It's a good start.
All right, I've got another hard question for you. How do you test race condition bugs?
Sorry?
How do you test race condition bugs?
Again, it's hard. Normally I do. I have a talk at DOSCON who talks a little bit about that actually, which is tomorrow. And normally you try to create race conditions. There's a library called JC Stress, JC for Java. It's not Java Champions, it's Java Concurrent. So it was used to test Java util concurrent library a long time ago. So when you use it, it will create tons of threads and use different parameters of the JVM to try to create collisions. It does work quite well in general, but of course it's for a limited scope of tests. So you do need where you want to make sure there's no race conditions. And of course it might not fail all the time, but JC Stress is the best way to make something fail, but some stuff are rarely failing, or they will fail on, not on Intel, they will fail on RAM or whatever. So there's no magic trick apart from trying on different CPUs and different flavor of JVM and try to put as much collisions as possible. However, another trick frequently used, especially when fixing a bug about data race collision, something like that, is to try to correctly order the code to reproduce the bug. So you add some hooks in between your code to be able to stop the code at the right place. You use like countdown latches or something like that, and it will, and so that way you'll know, okay, I'm at that place precisely, and now I'm at that place, and now I make it fail, and you go like that. So you try to order and make sense of the randomness of threading, and that's also helpful.
Cool. What do you think about the cardinality of classes to tests? In particular, should you always have exactly one test per class, or are there scenarios where you might have more than one test class per regular class?
I've answered that. Group them my teams. So yeah, no, do not have one class per one test class per production class. Try to split them. So the easiest I found is, as I said before, group them by reusability of the things that you need for your test. That's like a good, in general, it will also be some kind of team there. And yeah, it's the best way to do it, to keep it small and nice.
Have you encountered any tools that attempt to generate tests? And if so, what do you think of them?
No, I saw, yeah, or yes and no. I've slightly tried one or two of them. The name doesn't come up to my head right now. Um, there are some interesting static analysis. I think like null away from, I don't remember the company, is looking for null around your code. That is interesting. I saw some frameworks that are generating test classes for by looking at the code inside. It's working, but then the test is not super pretty. So I haven't been convinced by that. One interesting thing that I think should be more popular in Java, but is widely used in JavaScript right now, is snapshot testing. So they will call a method with some parameters. They will get the result. They will save it somewhere, and then you do a refactoring. You rerun it, and you're expecting the snapshot to be the same. So I found that a really good solution to this kind of problem. It's helpful, especially if you have a good sample of data you might pass to that thing. But snapshot testing is, yeah, something I'm looking at right now.
Do you have any thoughts on when you should refactor your high-level design and architecture versus when you should just start over?
I almost never start over. We as developer, we like to start with a blank sheet. A lot of attempts of doing that have been huge failures. So in some cases you are forced to, like if you have, I don't know, some COBOL from 1972 to migrate to something, of course you won't refactor COBOL from 1972, but still you will want to deploy part of this replacement and then bigger part and a bigger part and a bigger part. If you, we like an example that I use in general is for Netscape. At some point they decided, hey, we did terrible things, so we should recode the entire Netscape to another thing, and it almost killed Netscape because it was fully buggy all over the place. And many companies have tried that, and it's always a mess, because if you take an application that has maybe 10 or 20 years of wisdom in it and you try to get functional specification to get something that works at the end, the functional specification always flawed. It's never fine. So try to refactor as much as you can. Replace frameworks, that works. Try to get to the place you want to be in the end, but restarting from scratch is almost all the time shooting yourself in the foot, from what I found.
We had two other questions about architecture. One of them was, does continuous refactoring yield the best architecture? And the other is, what happens when the code base doesn't have a coherent architecture to begin with? Would refactoring help with that, or do you need patterns like parallel change to make it happen?
In general, with simple tricks like I did, you get at least the unit test part. You can add integration tests. Sometimes the architecture is really flawed. And I will try to keep the functional code, but I will move it around in terms of architecture. I do use things like ArcUnit, which tests like all the architecture should be. It makes sure that the correct objects are using at the correct place. And and I will use that to try to move things around. I try as well to simplify as much as I can what I see as an architecture. A lot of this can be automated as well. Um, Frequently arriving on a project, I will just run like IntelliJ automated cleanup, and then I'll start working on the project. um, what else can I say about that?
No, that was good.
Yeah. Okay. Sounds
Do you
enough.
have any opinions that you're willing to share on YouTube about Mockito or JMock?
um, I shared about it before. Um, JMock I haven't looked for a while, and I know they had little new patterns that are more BDD oriented and they look interesting. So I won't talk about JMock too much. Mockito. Um, so EasyMock right now I develop it when I can, but I'm not developing it as much as I would like. If someone wants to work with a Java champion who did a really useful framework, please raise your hand, and I'll be really happy to invite you to help me out on EasyMock. And which means that Mockito currently has a bunch of features I would like to put in EasyMock because they're actually nice. So Spy is a bit like a partial mock, for example, but it does you can actually directly pass an existing class. That's nice. The verify concept is a good idea as well. So there are many things that are right in there. Um, the the things that I deeply hate is the fact that when there's no replay in Mockito, and because of that, you get a lot of strange errors because code that is supposed to be mock is not actually mocks, and so your test is now failing, and it especially occurs when you're migrating Mockito version because they tend to change the behavior of their matchers, so everything goes crazy. And when they do that, then you go and you lose hours trying to find out where the stupid mock is not mocked anymore and where it just returns null by itself. And there are tricks to be like you can add some settings to be able to see a bit more what is happening. And but when you use EasyMock, it never happens because EasyMock wants you to record everything you need, at least in the standard mode. So if so, you will just record, and then the test will directly fail on the thing that should not be called when you need it. And it even happens to me that I'm in front of some Mockito code that doesn't work. I get so upset that I just replace it with EasyMock to see it fail at the correct place. Then I put Mockito back because the library they're using is Mockito, and now I'm happy. So this drives me fully insane, and I do not think it's the good way to go. I think the early fail, but the spirit is different. So Mockito tries to be nice and return a value all the time, and in general, the test will break less when you use Mockito. However, with EasyMock, it will break more, but in general, it breaks for an interesting reason. So you should look at it and say, am I supposed to now call this method? Oh, no, I'm not. That's weird. So now you know you just broke something. I prefer my test to break more than more resilient, but less testing-ish. Yeah.
At what point in the process do you decide to refactor? Say you're working on a new feature. Do you refactor as soon as you notice something, or wait until the feature is done and refactor then?
Oh no, never. Never. I'll lose way too much time. In general, I refactor when I'm struggling testing. So when I start to implement a feature, I check if there's tests already existing, and if they're not, I'm adding them, and then if I'm struggling adding the test, everything comes from the test. If I'm struggling adding a test, I will refactor up to the point I'm able to correctly test with the test that looks good. And when I'm done, I do a feature, and my feature will be coded and like super quickly because now the code is clean and easily workable on. One of the things is, as I said that, I almost never start a server because I just do everything with unit test. I stitch things together and then I check if it works. But all the classes are behaving exactly the way I intended it. So if I have problems when starting the application at the end, it's just integration issues. It's nothing more. So so it goes really, really quickly by doing that. Starting a server is super, super slow, even if you have like a fresh restarting server. So
Did you encounter any interesting problems with generics when you were working on EasyMock?
ooh, that's a broad question. Yes. I would say that's out of the scope of this talk. But yes, erasure caused a lot of issues. I even had one lately. I've changed the behavior. If you're like, if it probably happened to you, if you're in Mockito and you're doing Mockito.mock and you're passing list.class, you get a warning because there's no way to get out of it. You always get a warning, and so you need to suppress the warning. In EasyMock, I got annoyed about that, so I decided that I would infer the type on the left side to whatever it is assigned to, and so they're disconnected with what I mock and what I return are now generically disconnected. So I don't have this warning anymore. However, the bad side of that is if you assign that to var, it doesn't work because inference won't work. And I also discovered that for Kotlin, it doesn't work that well either because they're not inferring the same way. So, so I'm not sure if I'll stick with it.
Got it. And that was our last question. For our audience, we're going to be taking a break tomorrow for DawsCon. There are lots of sessions tomorrow at DawsCon. Check it out. And we'll be resuming J Champions Conference Monday at 9 a.m. with Duke's Star Trek with Java 15 challenges. I posted the YouTube link to that in the chat. Thank you all for coming and have a good evening.
Thank you very much for attending. Have a good evening.